Okay, hello algebra students. We're going to work on solving systems of equations by another method today called the elimination method or the addition method. So I'm going to share my screen with you so you can see the presentation. Except it's looking really weird. I don't know why it's doing that. There we go. So the elimination method uses the fact that when you add a number to its opposite, you get 0. For example, if you add -5 to 5, you get 0, or 12 to -12, you get 0, or -7x to 7x, you also get 0. So it asks, what would you add to 3y to get 0? And hopefully you said that you would add -3y. So let's see if I can get my tools here. Hold on. Where are my tools? Let's go back. Let me find some tools. Let's figure out it's more. No. Let's go back. Oh, there we go. All right, so, sorry, I'm having some technical issues today. We want a pen. Now let's go with this, and can we choose a color? Yeah, all right, let's go with red. So we asked, what can you add to 3y to get 0? And hopefully you said -3y, because -3y plus 3y would be 0. All right, let's go to the next slide. All right, so we have some vocabulary to write down on page 144 in your journal, and is the definition of coefficient. Go ahead and draw that example in there too, with the arrows pointing to those numbers in front of the variables, because those are the coefficients. So pause the video and write those down. All right, I'll grab my eraser here. All right, let's look at the next slide. All right, so the step-by-step procedure for solving by elimination, we're going to follow along. The guide to this step-by-step process is in your journal on page 144. So the first step says to multiply, if necessary, one or both equations by a constant, so at least one pair of like terms has the same or opposite coefficients. All right, so we look here in this example. I'm going to grab my pen again. And we have opposite coefficients right here, right? If we look, we have x and -x. So if you see that, then you can go along to step 2, which says, add the equations to eliminate one of the variables. So I'm literally going to do that. I'm going to erase this a second here because it's kind of messy looking. Go back to my pen. So if I look, if I add these two equations together, and it's important we understand that we're adding here, x plus -x would be 0. 3y plus 2y is 5y. And 17 plus 8 is 25. So I now have step 3, which is solve the resulting equation. So I now just have an equation. I need to solve for y. I'm going to divide both sides by 5. And I get that y is equal to 5. Now, remember our solution to a system of equations is an ordered pair. And we had this in the last couple sections. In this case, I found out my y coordinate was 5. So I now need to go and find my x coordinate. Your options are at this point to go back to your original equations and put that 5 in for y, either into my top equation or my bottom equation. It doesn't matter. Either way, I'm going to end up solving one of these equations for x after I substitute y. So I'm going to grab a different color here. Let's go with orange. right? And I'm going to replace this y right here with 5. So this top equation is now x plus 3, but instead of y, I'm going to put in my y value, which is 5, equals 17. So I solve that equation, x plus 15 equals 17. Subtract 15 from both sides, and I get that x is equal to 17 minus 15, which is 2. So my solution is the ordered pair 2, 5. Remember to check that. You can plug these variables back in. So let's see, 2 plus 15 equals 17. It works there. And negative 2 plus 10 would equal 8. So it works in both equations. All right, let's look at another example. Let's go on to our next slide. All right, this is extra practice problem number 2. Or excuse me, extra practice problem number 3. Let's erase all this. Come on. All right, I'll grab my pen again. Let's go with A. Hopefully that'll show up. All right, so this time, remember, you're always looking to see if you have some opposite terms lined up. All right, do I have my pen? Hopefully. All right. Do I? Yeah, there we go. So if I look, I have 2x and negative 2x. Those are opposites. These are not opposites. So since I already have my opposite terms, and this is what you're looking for, your next step is to add the two equations together. So 2x plus negative 2x is 0. 3y plus negative y is 2y. And 10 plus negative 2 is 8. And again, to get that, we added these two equations together. That's what the elimination method does. It's sometimes called, you'll see some books or places refer to it as the addition method. So now I'm down to 2y equals 8. I'm going to divide both sides by 2. And I get that my y value of the system is 4. All right, fix that. Again, I'm going to write down here part of the solution that I know, which is that my y value is 4. So I'm going to have to find my x. Again, to find my x, I go back to my original system, and I either need to replace this y with 4 or this y with 4 and solve for x. So I'm going to pick the bottom equation this time. Again, remember, it doesn't matter. So I'm going to replace this y with 4. So my second equation is now negative 2x minus, but instead of y, I put y's value, which is 4. And it says that's equal to negative 2, right? I've just rewritten the second equation, substituting in my y value. So now I can add 4 to both sides. And I get that negative 2x is equal to negative 2 plus 4, which is 2. Divide both sides by negative 2. And I get that my x value is 1. And I plug that into my solution. All right, remember, I can check. I'm just going to do that just kind of mental check here. So I have 2 times 1 is 2. 3 times 4 is 12. Oopie, did I miss a sign? 2 times 1 is 2, plus 3 plus 4 is 12. It's giving me a 10. So it looks like a mistake. What I miss here? Oh, right here. Whoops, let's go back. Good thing I checked. This is a negative 2, which means this is negative 1. All right, now let's check. So 2 times negative 1 is negative 2. Plus 12 is 10. There we go. It works that time. And second equation, a negative 2 times a negative 1 would be positive 2. Minus 4 is negative 2. All right, so that's why it's helpful to check. So I had missed this negative here. So our solution should be negative 1, 4. All right, let's try another one. I'm going to erase those. All right, this time we're going to look at, all right. This time we have extra practice number 6. Let me double check. Yep, we did 3. Now we're going to look at extra practice number 6. All right, I'm going to grab my pen this time. Um, I'll stick with that yellow. So right now we have 2x minus 5y equals 8 and 3x plus 5y equals negative 13. Again, remember, you're looking at the system to see if you have opposites lined up over each other. So 2x and 3x, those aren't opposites. But here I have a negative 5y and a positive 5y. Those are opposites. When I have my opposites, my next step is to just add the two equations together. So I have in this column 2x plus 3x is 5x. My y's are going to cancel because there's opposites. So negative 5y plus 5y is 0. So those cancel. And 8 plus negative 13 is a negative 5. So I keep solving for x this time. Divide both sides by 5. And I get that x is equal to negative 1. All right, so I'm going to start writing my solution. I know my x coordinate is negative 1. So I write that down. Oops. Erase that. All right. So grab my pen again. Close my parentheses. All right, and now I need to plug that x value into my original system and find a y value. So I can either plug that x coordinate in here for this x or in here for this x and solve for y. I'm going to go ahead and use the top equation this time. Remember, it doesn't matter where you substitute it. So I'm going to take this top equation and I'm going to replace this x with x's value, which is negative 1. So I'm going to write 2 times negative 1, that's what x is equal to, minus 5y equals 8. So negative 2, or negative 1 times 2 is negative 2, minus 5y equals 8. Add 2 to both sides. And I get negative 5y is equal to 10. I'm going to divide both sides by negative 5. Hopefully I won't miss my negative this time. And I get y is equal to a negative 2. All right, so I'm going to check my system, make sure I didn't make any mistakes again this time. So let's see, 2 times negative 1 is negative 2. A negative 5 times a negative 2 is a positive 10. Negative 2 plus 10 is 8. In the second equation, if I plug it in, 3 times negative 1 is negative 3. 5 times negative 2 is negative 10. And a negative 3 plus a negative 10 is a negative 13. All right, so we did it right. All right, let's go on to our next slide. Okay, we're going to look at example 12 this time. Erase all the work from the previous slide. All right, so again, you're looking at your system of equations. You want to have opposites lined up over each other. All right, so if I look this time, let me grab my pen. If I look here, I have 9x and 3x. Those are not opposites. I have 4y and negative 10y. Those are not opposites. So in this case, I'm now on a different process. I need to, let's see if there's some notes in your journal on this. No. So if you don't have like terms lying under each other, you need to multiply one or both equations by a number to get opposites. So if I look here, I have 9x and 3x. All right, in order to be opposites, I would really like this 3, instead of it being a 3, to be a negative 9, because then 9x plus negative 9x would be 0. All right, or I could look at the y's. I have a 4y and a 10y. So trying to get something that would make those opposites, well, I know both 4 and 10 go into 20. So if this were a positive 20 and this were a negative 20, those would cancel. So you have a couple options here. So the easiest way to get opposites would be if I look at these two and I try to change this 3 to a negative 9. So to do that, remember in algebra that we can do something to an equation as long as we do it to both sides. So I'm going to multiply both sides of this equation by negative 3. Remember, this is the multiplication property. I can multiply both sides of an equation by a number. As long as I do it to both sides, it does not change the value of the equation. So this second equation is now negative 9x. I have to remember to multiply everything by that negative 3. Negative 3 times negative 10 is a positive 30y. And on the other side, I have negative 2 times negative 3 is a positive 6. All right, if it helps you see it better, let's just go back and write this equation or this system all over. So I still had 9x plus 4y equals 11. I haven't changed anything in that first equation. The second equation, however, instead of being 3x minus 10y equals negative 2, is now negative 9x plus 30y equals positive 6. And again, to get there, remember we multiplied both sides by something that would get these variables to cancel. So now I can add these two together. My x terms will cancel because they're opposites. So 4 plus 30 is 34y. And 11 plus 6 is 17. So I'm going to divide both sides by 34. And I get that y is equal to, and notice, this time the top is smaller than the bottom, but 17 goes into 34 2 times. So this fraction reduces to 1/2. And that's the y value of my solution. So I'm going to write that down. I know my y is 1/2. Okay, at this point, to find my x value, I actually have 3 options of places that I can substitute this time, right? I have a y here, I have a y here, and I have the y I got when I rewrote that second equation. So you can substitute that y value of 1/2 into any one of these y's and solve for x. I'm going to go ahead and use the top equation just because it's convenient, and I'm just going to multiply by 4, which is nice. So I have 9x plus 4 times, and remember our y value is now 1/2, and that's equal to 11. So I keep going. I have 9x plus 4 times 1/2 is the same thing as half of 4. What's half of 4? 2. I keep solving. I subtract 2 from both sides. And I get 9x is equal to 11 minus 2, which is 9. Divide both sides by 9. And I get that x is equal to 1. And I put that on my solution, right? I can double check. 9 plus 2, right? Half of 4 was 2. 9 plus 2 is 11. If I plug it in here, 3 minus 10 times 1/2 is 5. So 3 minus 5 would be negative 2. I could plug it in here. Negative 9 times 1 is negative 9. Half of 30 is 15. Negative 9 plus 15 is 6. Okay, so this is my solution. All right, I think we have another one of those to look at, which is good. So let's put our mouse and go to the next slide, hopefully. Come on. Do some erasing. All right, so this time, example 11, we also have a case where we do not automatically have things lined up as opposites, but that's okay. We can figure it out. And my color might not show up too well. Let's try a different one. All right, so if I look, I have 3x and 4x, not opposites. I have negative 2y and negative 3y, not opposites. So I can either choose a number that both 3 and 4 go into, like 12, or choose a number that 2 and 3 go into, like 6, and get one of the variables to cancel, either x or y. So I'm going to go ahead and try to eliminate my y's. So I know that 2 and 3 both go into 6 evenly. So I am going to, hopefully I have my pen here, it's not looking like I do. I'm going to multiply this top equation by a positive 3, because 3 times negative 2 is equal to negative 6. So if I multiply this equation by a positive 3, this is going to turn into a negative 6y. All right, so that's super handy. All right, my bottom equation, I'm going to switch pen colors because that is crazy color. Kind of hurts the eyes. Let's try green. All right, this time, remember, I'm trying to eliminate y's. I'm looking at this column here. All right, so now I figured out a way to make this top thing a negative 6y. So if that's going to be negative 6y, what do I need to multiply this bottom equation by to make this a positive 6y? So 3 times negative 2 was negative 6. I need a positive here now. So if this is negative, I need to multiply by a negative to get a positive. And again, I'm doing that because negative 2 times a negative 3 will be a positive 6. So the only way to get opposites, or to get them to cancel, excuse me, is if you have opposite signs. All right, so I'm going to rewrite I'll read my bottom equation first, just because I still have the green pen. So negative 2 times 4x, and remember you're doing this to both sides. So negative 2 times 4x would be negative 8x. Negative 2 times negative 3y would be positive 6y, and that's good. Remember, that's what we were trying to get. Equals, and I have to remember to multiply this side as well. Negative 2 times negative 4 is a positive 8. All right, I'm going to go back to that crazy pink. I'm going to multiply the top equation. 3 times 3x would be a positive 9x. 3 times negative 2y would be negative 6y. Equals, and 3 times negative 2 here would be negative 6. All right, I'm going to switch colors. So now I have negative 9x and 8x. Those aren't opposites, but I got what I wanted here. I have a negative 6y plus 6y. Those are opposites. So remember, at that point, once you have your opposites, you can add the two equations together. So 9x plus negative 8x leaves me with 1x. Negative 6y and positive 6y cancel. And negative 6 plus 8 is 2. So I have in my solution my x value. Notice I didn't have to divide anything. I automatically just got 1x. So in my solution, x is equal to 2. I now need to take this 2, and I either can plug it into one of my original equations in place of x, so I could put it in here, or I could put it in here, or I can plug it into either one of my rewritten equations, so I could put the x in here or here. I'm going to go ahead and put it in the top equation. Again, remember, it doesn't matter. So my top equation was 3x minus 2y equals negative 2. But I'm now going to substitute this answer here. I got x was 2. So I'm going to do 3 times 2 minus 2y equals negative 2. So that gives me 6 minus 2y equals negative 2. Subtract 6 from both sides. And I get negative 2y is equal to negative 8. Divide both sides by negative 2. And I get that my y value is equal to a negative 4. So I'm getting a call here. Let's see if I can cancel that. All right, negative 4. All right, so let's double check our solution. 3 times 2 is 6. Negative 2 times negative 4 is positive 8. Did I miss a sign again? Yes, there should be a negative 2, and this is a positive 4. Boy, I'm having trouble with signs today. Let's erase that. Go back to our pen. Good thing I'm checking. There should be a positive 4. All right, so now let's check. So 3 times 2 is 6. 6 minus 8 is negative 2. Let's check here. 4 times 2 is 8. Minus 3 times 4, which is 12. 8 minus 12 is negative 4. I could also check it in here, but these are all good to go. All right, let's look at our next slide. All right, looks like that's the assignment. I'll erase this so you can read it. All right, this is in your book. The link to the textbook pages are in Schoology. If you have any questions, you can email me, I can answer. or you can ask me in class as well. You can also find this topic online, either in Khan Academy or look on YouTube, and it's solving systems of equations by elimination, or you can also see it called the addition method. All right, good luck.